For more information, please visit SGMAK Associates website.
Hi, here is another audio file on solution to some of quadratic equations. What I have here is a number of problems. Every problem statement is followed by a short solution, and in some places maybe add some comments. So let's go through this one. First problem is find a number that is added to its reciprocal generates a sum that equals twice the number. So if the original number is x, reciprocal is 1 over x. So when you add reciprocal to the number, x plus 1 over x gives you twice the original number, 2 times x. So that's how you convert problem statement to equation. And so if you simplify, so it becomes x equal 1 over x, or x squared equal 1. So there are two values for x, plus 1 or minus 1. So there are two solutions to this problem. One is plus 1, other one is minus 1. Moving on, let's look at the next problem. It says find the roots of a quadratic equation. Roots that differ by 2 and the product is 24. So let's say the roots are R1 and R2, and arbitrarily I'm saying R1 is the larger one, but basically the difference is 2. R1 minus R2 is 2, and product is 24. So two equations, two unknown given, you have to find the values of R1 and R2. So in this case, we are solving for R1 and R2. So we can find with this expression R1 minus R2 squared plus 4 times R1 times R2. That equals R1 plus R2 raised to the power 2. So R1 plus R2 is plus minus 10. R1 minus R2 is 2. So you got two sets of solution. One for R1 plus R2 equals 10. And then that gives you solution 6 and 4. Other one is R1 plus R2 equal minus 10. That gives you solution minus 6 and minus 4. So roots are 4 and 6, and minus 6 minus 4. Written away from left to right, the number is increasing. Okay, moving on to the next. The equation is given as x squared minus 2 times square root of 7 times x minus 2 equals 0. See, if we map it with this general formula, ax squared plus bx plus c equals 0. So a is 1, b is minus 2 times square root of 7, and c is minus 2. So you can find the roots as minus b plus minus b squared minus 4ac divided by 2a. And that gives us roots as 3 plus square root of 7, or square root of 7 plus 3, and square root of 7 minus 3. Two roots. Alternately, what you can do is any quadratic equation you can set it up as a perfect square plus or minus something. So in this case, what you can do is we can write the original equation as x minus square root of 7 squared equals the right hand side becomes 9. So we are not solving you're not using the typical formula for finding the roots of a quadratic equation. In this case, if you take the square root of that expression, x minus square root of 7, that becomes plus minus 3. So that gives you two roots, 3 plus square root of 7 and minus 3 plus square root of 7. Two different ways of solving the same problem. Let's look at the next. So 1 over a plus b plus x equal 1 over a plus 1 over b plus 1 over x. So what you can do here, we just take 1 over x, that term, onto the left. So all x we bring on one side. So 1 over a plus b plus x minus 1 over x is 1 over a plus 1 over b. Then if you factorize as shown here, you get a quadratic equation, x squared plus a plus b times x plus ab equals 0. So some of the roots minus a minus b, and product is a times b. So roots are minus a and minus b. You can always put the roots back, individual root back in the equation, original equation, and validate that it satisfies. Let's move on. Other one is 1 over x plus a, 1 over x plus 2a, 1 over x plus 3a is 3 over x. Now, we make an assumption here. A is just a general parameter. So let's say x is k times a, and k is unknown. So with that simplification, the equation changes to 1 over k plus 1, 1 over k plus 2, plus 1 over k plus 3 equals 3 over k. So we're dealing with one variable k here. And then through this simplification, we get this expression 1 over k plus 1 plus 2 over k plus 2 plus 3 over k plus 3 equals 0. And k is not equal to 0. So then you convert that into quadratic form and find the roots to be one root is 1 by k1 is 1 over 6 in the bracket minus 11 minus square root of 13, and k2 1 over 6 within the bracket minus 11 plus square root of 13. And the original, in terms of original variable, there are two values for x, a times k1 and a times k2. Think about the problem. If you have any comment, send us an email. Let's look at the next problem. If you have two quadratic equations, x squared plus 2cx plus b equals 0 and ax squared plus 2bx plus c equal to 0, they have a common root. Both equations have a common root. Quadratic, so there are two roots, but they share one root. One root is valid for both. So let's say that value is alpha. Then you satisfy first equation, so we get a alpha squared plus 2 times c alpha plus b equals 0. You satisfy second equation, so alpha squared plus 2b alpha plus c equals 0. Then if you simplify, we get alpha as 1/2. So the common root is 1/2. Now if you put it back in the quadratic equation, the first one, we get a over 4 plus 2c plus b equals 0, or a plus 4b plus 4c equals 0. Okay, so that's what we're looking for. The problem says what is the value of a plus 4b plus 4c, and the value equals 0. Okay. The real values for find the real values of a for which the quadratic equation. So basically what you're saying, find the values of a for which the quadratic equation given will have roots there of opposite sign. So always if you have ax squared plus bx plus c, it's a good idea to write it in a form so the x squared has a coefficient 1. So convert into x squared plus b over ax plus c over a equals 0. In that form, some of the roots are minus b over a and product is c over a. So if we rewrite the equation, we write x squared minus 1/2 a cubed plus 8 times a minus 1 times x plus 1/2 a squared minus 4a equals 0. Now some of the roots are 1/2, some of the roots are 1/2 a cubed plus 8a minus 1, and the product is 1/2 of a squared minus 4a. Since the roots are of opposite signs, the product has to be negative. So that implies a squared minus 4a has to be negative. So it will be negative for a value of a between 0 and 4. Okay, if you pick up a value which is greater than 0 but less than 4, then a minus 4 will have a negative value and the product will be negative. Okay, again, if you have any comments, let us know. Next problem, b squared plus c squared minus 2 times a plus b into x, a plus b times cx plus c squared plus a squared, they have two equal roots. So if they have two equal roots, best is to find the discriminant and set that equals 0. And if you set that equals 0, in this case you find a times b equals c squared, so which is the same as, which happens when a, c and b are in a geometric progression. So c over a equals b over c, and that gives you a times b as c squared. So, if the quadratic equation as shown here has equal roots, then a, c, and b are they are part of geometric. They are in geometric series. A geometric series, the property is if you take two consecutive numbers, the ratio remains the same. So in this case, a, c, b. So c over a will be equal to b over c. Okay, let's check the next. If alpha and beta are roots of the equation ax squared plus 3x plus 2 equals 0, a is less than 0. So alpha plus beta is minus 3 over a, and alpha times beta is 2 over a. Some of the roots and product of the roots. Now, since alpha beta are roots, so they both satisfy the original equation. So a alpha squared plus 3 alpha plus 2 equals 0, as well as a beta squared plus 3 beta plus 2 equals 0. Now you have to evaluate the value of this expression, alpha squared over beta plus beta squared over alpha. So if you just go through the algebra and use the value information that alpha plus beta is minus 3 over a and alpha times beta is 2 over a, you get a value minus 3 times 9 minus 6a divided by 2a squared. Now a is less than 0. Now a is less than 0, a squared is positive. So we'll say that the expression is less than 0. A is less than 0, so a squared is positive. So whole expression is less than 0. So alpha squared over beta plus beta squared alpha is less than 0. All right. If a is not equal to 0 and b not equal to 0, and alpha beta roots of the equation x squared plus ax plus b equals 0, then we know alpha plus beta is minus a and alpha times beta is b. So that's with the equation x squared plus ax plus b with roots alpha and beta. So what will be the equation whose roots are 1 over alpha and 1 over beta? So which is given by x squared minus sum of the roots times x times plus product of the root equals 0. And then if you simplify, that leads to bx squared plus ax plus 1 equals 0. Okay, pretty straightforward. Okay, let's move on. Uh, what is the equation, quadratic equation whose roots are minus alpha and minus beta, following up on the previous problem? So again, x squared minus sum of the roots times x plus product of the roots. So that gives you x squared minus x plus b equals 0. What if the roots are alpha over beta and beta over alpha? Following the same logic, the equation is bx squared plus 2b minus a squared times x plus b equals 0. So we're simply utilizing the relationship sum of the roots and the product of the roots. And for any quadratic equation, the equation can be written as x squared minus sum of the roots times x plus product of the roots equals 0. If a, b, and c are in geometric progression, then the equations ax squared plus 2bx plus c equals 0 and dx squared plus 2cx plus f equals 0. If they have a common root, then d over a, e over b, and f over c are in arithmetic progression. So we are given two equations have a common root. So first thing, a, b, c are in GP. So b squared is equal to a times c. So we can write the equation, original equation, as square root of ax plus square root of c squared equals 0. So the roots are minus c over a and minus square root of c, identical roots. These two equations have a common root. So the root must be minus square root of c over a. So that satisfies the second equation, dx squared plus 2cx plus f equals 0. So if you plug in the value, we get d over a plus f over c equals 2 times c over b, utilizing the equation that b squared equal ac. So you get d over a plus f over c is 2 times c over b. So that means d over a, c over b, and f over c are in arithmetic progression. In arithmetic progression, the successive terms have the same difference. Okay. If alpha and beta are the roots of the quadratic equation x squared minus 6x plus 1 equals 0, alpha plus beta equal 1, and alpha beta product is 1 over 6 for the same equation. Then you're asking to find the value of an expression that involves a, b, alpha squared alpha cube and beta squared beta cube. So, just through manipulation, it comes out to be b times alpha plus beta, c times alpha squared beta squared, d times alpha cube beta cube, and the value of alpha plus beta and alpha beta. This number comes out to be a plus b over 2 plus c over 3 plus d over 4. What happens when you have an equation that x equal infinite expression, repeating expression under the square root sign? So x equals square root of 2 plus and a repeating expression under square root of 2. So that expression repeats itself. Every time you take a step, we get another square root and the expression comes back. So you can write it as x as square root of 2 plus x. That gives a quadratic x squared minus x minus 2 equals 0. And values of x are minus 1 and 2. So in this case, minus 1 will not accept. So the admissible value is 2. If a, b, c are real numbers and a is greater than 0, find the minimum value of the expression x squared plus bx plus c. So what you can do here, we can divide each term by, or you can take a outside the expression and then convert what's remaining as a perfect square plus something. So we get a times x plus b over 2a squared plus 4ac minus b squared over 4a. So the first term is a perfect square, so minimum value will be 0. So minimum value of the expression is 4ac minus b squared over 4a. And that happens for value of x that drives the first term equals 0, where x equal to minus b over 2a. Okay. Hi, we are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.